Most of our reactions that take place will occur in an aqueous water-based solution. And so it's important to be able to express how much of the actual reactant we have in a given volume of solution. So we need to understand the concentration of that solution and how we can express that. Now, there are different ways to express the quantity of solute that is in a given volume of solution. Some familiar units are parts per million. So out of every million particles, how many parts are the solute in question or the substance in question, or parts per billion. There are other ones, normality or molality, which take a look at how many moles of substance there are per kilogram of solution, or how many particles there are in a given unit, volume unit. But the one that we are most interested in and going to use most frequently is that of molarity. Molarity is symbolized by a capital M, and it is equivalent to the unit's moles of solute per liter of solution. Again, molarity is going to give us a ratio, a relationship between how much solute in terms of molar quantity, moles, divided by the volume of the solution. And that volume is usually in liters. Now, please note that it is the volume of the entire solution, the water and the solute mixed together. It is not in terms of the volume of water added. When we solve for concentration, we will be given a starting amount of solute, usually in grams, because that's how we would measure out a solid reagent that we are going to be dissolving to make a solution. And we will also be given a final volume for that solution. And so we start by putting the original amount of solute over the original volume, and then we take that ratio and we simply convert each of those units into the necessary units for amount of solute and volume to moles and liters respectively. Now, when working with liters or volume, remember that there are some equivalent values, whether we're talking about cubed length units or our metric units for volume. So 1 cubic decimeter and 1 liter are identical. These are both equivalent to 1,000 cubic centimeters and 1,000 milliliters. So you can use these relationships as conversion factors depending on what your starting volume is. So if we take an example, we're asked what is the concentration in molarity of a 250 milliliter solution that contains 9.46 grams of cesium bromide. So if we remember our original setup, we take the amount of solute we're given and put it over the volume of the solution. So in this case, it would be 9.46 grams cesium bromide over 250 milliliters. And we need, for molarity, the units to be moles over liters. So the first step is to convert the units, and we'll take the grams first. We'll convert grams to moles using the molar mass of cesium bromide, which computes to 213 grams of cesium bromide. The grams of cesium bromide will factor out, leaving us with moles on top. Now for the volume units, we have milliliters on the bottom, so our next conversion factor needs to be 1,000 milliliters over 1 liter, so that the milliliters can cancel. And now we have units of moles over liters, which is what we need for molarity. So when we plug these numbers in and we calculate our answer, we should come up with 0.178 moles of cesium bromide per liter. The more common way to express molarity is with the capital letter M as the unit, so we can rewrite this as 0.178 molar CsBr.